Today's lesson's on laws of exponents. Let's look to the product of powers. X cubed, that's 3x's, x to the 5th. So when we multiply all those, we have x to the 8th power. X to the 4th, we have 4x's, x to the 7th. How many x's do we have? We have 11, x to the 11th. Do we see there if there's a pattern? Yes, there is. What's the rule? That we add the exponents. Let's look at two more. Let's just, here, now we know the rule. We're going to add 6 plus 3. And we have x to the 9th power. I would like for you to do the next one. Now let's look at another one. Here, what's the difference? We have coefficients. Our rule still stays the same with my exponents. And I multiply my coefficients. 30. 3 plus 5 is 8. Multiply coefficients. Add the exponents. Remember, we should be checking here using our calculator. Do we have a rule where we add our exponents and we take the coefficients and multiply them together? Let's look at another one, power to a power. Here we have x squared to the 5th power. So I'm going to write x squared 5 times. What is x squared? We have x times x. How many x's do we have? We have 10 x's, so we have x to the 10th power. X cubed 4 times. And we have 3 x's here, 3 x's here, 3 x's here, 3 x's here. How many x's do we have? We have x to the 12th power. Do we see a pattern here? 2 and 5 were 10. 3 and 4 is 12. Our rule is we multiply the exponents. So now we know the rule. We're just going to do 3 times 7, which is 21. You try the next one. Here we have a coefficient, so what's the difference? We already know. What are we going to do with my variables? And we're going to do what with our exponents? Multiply them. Now, what do we do with the coefficient? Well, if we take the variable out, we would just have 3 to the 5th power. 3 to the 5th power is 243. 2 times 5 is 10. So we got 243 x to the 10th power. Let's look at the next one. Act like the variable's not there. So we're going to do 2 to the 4th. And we take our exponents and multiply them. 2 to the 4th, 16. 3 times 4 is 12. Do we have a rule? Okay. We know we multiply our exponents and we raise the coefficient to the exponent. I'd like for you to try these two problems using the rule from the previous slide. Now we have a power of a product. What do we do here? Well, let's break this down. Act like we don't have y to the 4th. Let's just rewrite it. I have x cubed squared Now that I'm going to act like I don't have x cubed, so I have y to the fourth squared. Now what rule is this? Yes, it's the previous rule where we multiply by exponents. X to the sixth, and 4 times 2 is 8. X to the sixth, y to the eighth. Remember, we should be checking using our calculator. Let's split this up. X to the fourth raised to the fourth power, y squared to the fourth power. Remember our rule. Multiply exponents. X to the 16th, y to the 8th. Do we have a rule? We take our two variables, split them apart, multiply by exponents. Like for you to try these two on your own. Now we add the coefficient. Still going to break it up. Now we're going to break it up into 3 pieces in this problem. Two to the 4, 16. Oh, there's that rule again. We're going to multiply our exponents. And we should check using our calculator. Let's break this up. Three to the fifth power, 243. Multiply my exponents. Do I have a rule? Multiply my exponents. And we're going to raise the coefficient to the exponent. You draw these two on your own. X to the fifth. We have 5 x's. X cubed. If we break this apart, x and x cancel out because it equals 1 if I divide x divided by x. So here I have x squared. X to the 7th. Divided by x squared. We have x to the 5th. And we see a rule. Where it's 5 and 3 made 2, 7 and 2 made 5. Yes, the rule is I subtract my exponents. You try these two on your own, just using the rule. Now, I've added a coefficient. Split this part. 6 divided by 3. That's 2. Remember our rule from our previous slide? We subtract the exponents. So 5 minus 3 is 2. Break it up. 6 divided by 12. X to the 7th divided by x squared. 6 divided by 12 is 1/2. X 7 minus 2 is 5. So I have 1x to the 5th divided by 2, or just x to the 5th divided by 2. We have a rule. We subtract our exponents, divide our coefficients. You try these two on your own using the rule. Power of a quotient. Let's look at this one. Does it look like a couple that we've already done? Well, let's split this up. X to the 5th raised to the 3rd power. Y to the 4th. Let's just look at the numerator. Does that look like a rule? We're just going to multiply my exponents, do the same thing in the denominator, x to the 15th, y to the 12th. X squared to the 4th power, y to the 5th, raised to the 4th power. We are going to multiply my exponents. Look at the rule. Raise everything inside to the exponent that is outside. You try these two on your own. Okay. This one looks like one we've already had. 5 minus 5 is 0. Let's look at that. We have 5 x's. What happened to them? They all canceled out. I was left with none. And we know x divided by x is 1. So all we had was 1's here. So this is 1. So x to the 0 is 1. 3 minus 3 is 0. So x to the 0 power. Last problem we said it was 1. It's 1 again. So anything to the 0 power is 1. That's my rule. Try these two on your own. So we have here x 3 minus 7, x to the negative 4th. Let's look at what happens here. Cancel out. We have x to the 4th and it's in the denominator. So anytime we have a negative exponent, we need to what? Make it positive and move it to the denominator. 2 minus 5. So we have x to the negative 3rd. Let's draw that out here. X squared. X to the 5th power. Cancel them out. We had 3 x's in the denominator, so they're going to be down there. So we're going to take the negative 3, make it positive, put x cubed in the denominator. Do we have a rule? We have a negative exponent. We make it positive and move it to the denominator. What happens if we had the negative exponent in the denominator? We would make it positive and we would move it to the numerator. You try these two on your own.